All right, so welcome to our video. This is going to be kind of the main stuff that we talk about. Excuse me for my camera, and we're going to be talking about geometry for chapter one. So what we're looking at here is a perimeter and area, something that again we're going to be dealing with a lot, especially throughout the year. So again, it's going to be something that you need to get kind of comfortable with. Again, remember perimeter. If you want to write yourself a note, perimeter is the outside figure of this. So again, the measure of the distance outside. And then again, area is the space that it takes up in the middle. So again, just make sure that you got that in mind when you're doing this. So what this activity is, it's kind of actually fun, and I think it'll have a lot easier connotation when you start kind of putting the pieces together. So you have all these plastic sheets, and again with these different figures. So you got A and B, and then C, D, E, and F. So what your job is today as a group is to kind of go through these together and then be able to kind of figure out, okay, what does figure four look like? What does figure five look like? And then at the end, okay, how can we put this kind of like for all instances, like figure 20? Obviously, you're not going to draw figure 20 again, because again, you won't have enough space either on your notebook or a piece of paper that you're using. But again, just keep that in mind. So what it wants you to do then is it wants you to kind of keep an idea of a table. So like what happens to the perimeter of the figure as it starts to go up. So in this case, again, you have a nice easy table here. So what I do is I label the figure um, number, or figure or how many it is. So obviously we'll have figure one, two, three, four. Then we have obviously five, and we'll have 20 down here too if you want. So just keep that in mind as well. And then the same idea for the table. So down here for the area. So again, they're all labeled. So perimeter area. Again, these do not have to be again very easy. They can be very easy sketches, I guess is the best way to say it. So you do not have to make them hard. But in this case, you got figure number here, and then you can go one, two, three, four, five, and then 20 again. And again, each figure, as you kind of go along with the graph, and then you can kind of label it. So you can go one, two, three, four, five. And again, you do not have to do 20, folks. Again, you get the idea. As you add the blocks, so again, whether you're counting the outside and the perimeter or the number of boxes within spaces here for those area, and just make sure that you keep that in mind. Now, the end goal is to eventually figure out, okay, what is happening with each of these figures. So in this case, the equation for both the perimeter and area. What you're going to hopefully notice is there's a pattern that starts to develop. Okay, so obviously you got different figures. Here's A, and then here's B. So they're all different in their own right. But again, does area and perimeter behave the same for each one of these figures? Exactly, excuse me, for that and all figures really, so like all different kind of triangles and such for those. So what I want you to do is again, go ahead and draw figure four. Again, it does not have to be fancy. So as you can see, our tile pattern is kind of increasing. So it looks like we start with one box here, and then we go to two boxes, and then we go to nine. So if we kind of keep that, it's going to be kind of a 4 by 4. So in this case, I'm going to go ahead and draw it. Again, keep in mind that my drawing skills are not great. So again, if you're like, I don't draw very well when Mr. Gibbs is just as bad as you. So in this case, you just do your best to kind of draw those. So here's my 4 by 4 boxes down here, and each one of them is increasing by 4. So if I look here again, I'm going to have obviously 3 by 3, 3 by 3. Now I'm just going to do 4 by 4 another time. So again, if you want to use a different color, actually I think I have a different color here. Give me a second. Oh, you can see it a little bit better. I'm going to go ahead and draw it. So here's the blue one, and then I'm going to do 4 by 4. So 1, 2, 3, 4, 2, 3, 4. All right, and then maybe orange again. So again, keeping with that same idea. So I'm going to go up top here, do 4, 4 again, 4, 4, 4, and then cross, cross, cross. Okay. All right, we're almost done. We're getting close. So we did the three, and then we got to do the two one. So obviously, as you can kind of see the pattern, it goes gray and gray, white and gray. So again, I'm going to kind of continue on that. So I'm just going to do the blue one up here, do 4 by 4 again. 2, 3, 4. Okay, perfect. Nice. I'll do 4 again. Again, keep in mind you can draw a lot smaller than me. So again, if you want to draw with this and less space. Again, help yourself out. All right, and last but not least, we got the one up top there. So I'm going to do that one in orange again, and we're going to end up having this one that looks like this up here. All right, so got all those figures. All right, so now you ask yourself this question. All right, so we drew figure four. Okay, now you do not have to draw figure five, folks. Again, if you kind of start to see the pattern, again, you do not have to draw them. But if you are struggling and you need the boxes to help yourself out, please do. Again, this is a great way to do so. So what I'm going to do is I'm going to go ahead and kind of start filling in my table. So in this case, on the bottom here, again, I told you to put the figure numbers 1, 2, 3, 4, and 5, and 20. So then that way you kind of get the idea. So we already have 1, 2, 3, and 4. So we'll kind of see, hopefully, if a pattern starts to develop here as we kind of go along. So first one I'm going to start with is the perimeter, just because it's on top. So in this case, I'm going to go ahead and count the perimeter. So I'm going to count the edge of the outside boxes. So keep that in mind. So in this case, I'm going to start here and I'm going to go 1, 2, 3, 4, 5. I know it's kind of hard to see, so I'm counting the sides. Keep that in mind. 6, 7, 8, 9, 10, 11, 12. So in this case, there's a total of 12 for the perimeter for the first figure for letter A. So I'm going to go ahead and put number, I guess you can call it number of sides, I guess, number of lines, depending on again with the perimeter. So there's 12 there. All right, so now I'm going to go ahead and do figure two. So in this case, I'm going to count the outsides and I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So there's 24 of those there. All right, we went from 1 and 12 to 2 and 24. All right, so let's see if patterns start to develop. See if we can do number three. So we go here and I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So I think I miscounted there one. 36. So in this case, that should be the one there. So 36 will be that value. Now, you may start to notice something. You say, well, Mr. Gibbs, look here. We got 12, we got 24, we got 36. Well, if this pattern keeps going, my guess is maybe by figure four, we actually might have a value of 48. And again, if you actually count, what you're going to notice is actually that value, if you go all the way around, is actually 48. So in this case, what you notice is that perimeter for the number sides actually is going up by a factor of 12. Now, what I want you to notice is, though, again, what is this pattern that's going up? So in this case, we went 48, we went to 60. And then if we keep the pattern going, we multiply, in this case, 5 obviously times 12 gives us 60. 20 times 12 is going to give us the value for the perimeter of, um, I think I have my numbers here, 240 here. So 240 with that value. All right, so now, again, what is happening with this figure? Well, in this case, if we draw the graph here for it, what you're going to notice is, and I can label it 1, 2, 3, 4, and 5, for example, and I do the numbers, and again, this is the figure number and number of sides, um, and go up. Again, you can go up any way you want. I'm just going to go by tens. So we go 10, 20, 30, 40, 50, and 60. Again, folks, this is very rough. So again, just keep that in mind. It does not need to be perfect. So again, if you need lines, again, I have graph paper up in front of the room, so just keep that inside. With that in mind, in 0, 0, obviously, figure number, you're going to have none. But figure 1, we have 12. So in this case, that would be like right here. 2 had the value 24, so we're like right here. 3 is going to be 36, it's like right here. 4 is that value of 48, right here. And 5 is 60 all the way at the top. Now, what you're going to notice is, again, very, very rough sketch, is they actually end up having kind of formed that line. And if you remember, what we call a line is actually what we call linear. So in this case, again, with perimeter, we actually saw that it kind of looks linear. So if we're going to write an equation for this, well, in this case, again, we're looking for an equation for the perimeter. So So what you may notice is, again, with that linear pattern, what we're going to do is we're going to do x and y here. So y is going to represent the number of sides, and then x is going to be actually, in this case, the number of figures that kind of go by. So what you're going to notice is, again, we're starting off that pattern 12. So the pattern actually, in this case, with the perimeter, and if you want to write p, you can please do so, is just going to be n multiplied by the perimeter, the first figure, which with this one, if you notice anything about it, is going to be, in this case, again, the 12 value. So therefore, we can write it as y equals 12. So that's kind of neat in this case, or 12x if you want to. So that's kind of neat. As you can kind of see, we kind of evolve from that idea from number of sides, and it goes up at that linear pattern. So again, maybe, just maybe, again, that perimeter will hold true for every single one of these figures. We'll see here in a second, but that's kind of the idea that we do so. Now, for letter B, or in this case, the table for the area, what I'm going to do now is, again, count the number of squares. So I'm looking and I'm saying, all right, well, number of squares, we can go ahead and do so. And with that in mind, folks, if you want to, actually, what I was just thinking, it kind of just popped in my head. If each one of you wants to do a different one, so that you can actually confirm, I will do this one and then probably one more, so that way you can kind of see the answers. But again, if you are feeling confident, please feel free to kind of do each one by yourselves, and then that way again, you can kind of compare notes and make sure everything's okay. With that part for the table, in this case, again, you got 1, 2, 3, 4, 5, and 20 again. So what we're going to do is I'm going to ask myself, okay, well, area is the inside, so I'm going to count the number of boxes. So my goal, again, is to count the number that we see. If we look, I'm going to count here for figure 1. I'm going to go 1, 2, 3, 4, 5, 6. So again, that value is 6. So I'm going to go ahead and put it there, and down here, I should say. Next one I'm going to do is I'm going to go ahead and count for figure 2. So therefore, I'm going to count here from the bottom. And I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So there's 24 in total there. Now I'm going to put that down here with this one. All right. Now, maybe you're starting to see a pattern, maybe you aren't. Again, that's totally fine. But again, we'll talk about those here in a second. Next one for figure 3, we're going to count. So this one, I'm not going to count the individual boxes because in this case, each one of them actually has 9 in like the different colors. So we can actually just go, so I can go 9 and then 1, 2, 3, 4, 5, 6. So I can just do multiplication quick. I can do 9 times the value of 6, excuse me, and get 4. So I'm going to go ahead and write figure 3, 54. Same kind of idea up here. So in this case, again, I have the value of 16 with each of these. So if you want to, you can go 16 and then 1, 2, 3, 4, 5, 6. 16 times 6 will give you the value for 4. In this case, I have the value of 96 there when I simplify. So 96 there for 4. All right. So maybe again you're noticing a pattern, maybe you aren't. Again, if you will feel free to draw on the values of 5, but again, we know each one of them is going to be worth 5 and 5, so it's going to be 25 times 6. So that value for 5 then is going to be 150. And then again, if you want to keep the pattern on rolling, 20. And then again, obviously, if you have 20 in each, so 20 by 20, and then the value multiplied by those numbers is going to be the value of 2400. All right, so now what you're going to notice here is those numbers are a lot bigger than what we had originally. So in this case, again, we had the number of sides with the perimeter. Those numbers are a lot smaller. But in this case now, what you notice is the area is actually a little bit growing at a faster rate, I guess you could say. So what I'm going to do is I'm going to go ahead and kind of label this. So we got 2400 there for 20. What I'm going to do, since we're at 150, I'm probably going to go by trying to think of the best way to do this to kind of see the expression. So maybe if I go by 20s, so I go 20, 40, 60, 80, 100, 120, 140, 160. So that'll fit at least well enough so you can see it. So what I'm going to do is obviously start at 0 with figure 0. I have 0 things there. The next thing I'm going to do is I'm going to go ahead and plot 1, 6. So 1 and then the value 6. So that's gonna be obviously way down here, because in this case, again, you got that value. 2 is gonna be the value of 24, so I'm gonna go ahead and put 2 and 24 here, just above the value of 20. 3, is that value of 54, so I'm gonna go ahead and put that up here. That's gonna be, like, right in between, like, 60 and 40. Again, using rough estimating skills here. 4 is the value of 96, so that one starts to kinda spring up a little bit, so that's gonna be, like, kinda, like, right here. And then number 5, if you kinda look, 5 goes all the way up, and all of a sudden you're, like, at 150, so you're kinda, like, right there. Now what you're noticing is you kinda and I'll draw in this line here, is you're noticing a different pattern. And in this case, again, that's interesting because if you look, what you actually have is you actually have a pattern there that kind of is increasing much steadier than that linear function. So if I'm looking there, what I'm actually seeing is I'm noticing actually the area actually looks like another word that we've used in the past. And you may have seen this in biology class when you're kind of either talking about like population, especially that's what we call exponential. So exponential functions obviously have that idea of finding the values, and all of a sudden they explode really quickly. And that's because, again, you're repeatedly multiplying each value after instead of adding like the perimeter. So if we were to write the equation for this, actually, what I'm looking at is I'm looking and saying, all right, well, why is the number of, why is the number of squares that were coming up. But in this case, again, if we're looking at the first figure, what I'm noticing is it's not just n that I'm multiplying by, so the number of figures as we go along, but it's actually what we call n squared. And the reason why that is because again, if we multiply and we plug in a value, 1 squared is 1. It's not going to give you a very big value. That's the reason why we're down here. But all of a sudden we do 5 squared, we end up getting the value of 25 multiplied with the value of the first figure, which is 6. We end up getting a really large number really quickly. So again, as you can see, the area actually increases by that value much quicker. So with that in mind, we also got to multiply that with the area of the first figure. So in this case, again, the number of blocks there, because that's our starting. That's like our initial value. So in other words, what we have is y is equal to the value of n squared, and then each one of them, since there's 6 of them in the first tile, is going to be multiplied by 6. And again, this works for any tile pattern whatsoever. All right. So again, as you can see, these kind of work all the same. So if you look again, you got the perimeter and area. Now, again, what I'd like you to do as a group, obviously, some of you may have watched this video initially. What I'd like you to do is at least try one for yourself. Confirm that this pattern actually does work. For me, again, I've kind of seen this a lot. So again, if you're looking for the data table, again, the data table actually is in CPM, so you can go ahead and log on to your online textbook and you can kind of see them. But again, I'll have the equations for you at the end here so you can kind of see them. But in this case, again, overall, again, not too bad. What I tell you is, again, just make sure that you're drawing the patterns so you get the idea, and then you can kind of figure out the value for yourself. But with that in mind, this is, again, the value, or excuse me, the section 113. Hopefully, again, this video finds you well. Again, if you're having a hard time understanding this idea of perimeter and area, make sure you come talk to me. Again, this idea is going to be used all throughout our geometry units. And again, we're going to be talking about it very vividly with that. So again, just understand that area again has a linear pattern, so a straight line, and the area with any figure has exponential pattern. So again, it grows rapidly. So with that in mind, have a great rest of your day. Make sure you're watching that video for simplifying. And again, your quiz for parallel and perpendicular will be coming up next week. Otherwise, have a great rest of the day. We'll see you all very soon.